Good morning. I bet you weren't expecting that. I certainly wasn't. My name is Anwar. I'm the current European co-chair of the PI-RADS committee. And I've been asked to give you a short overview of where we are today and why we've not moved on from where we were a year ago and what are the barriers. So, what changed in 2019? In 2019, we published the PI-RADS 2.1 version. And there were a number of changes that we made within the PI-RADS committee. But many of you did not notice this paper. This paper was published on the PI-RADS pathway. And the first version of the pathway you can see on the right-hand side of this graph. And this was based on an analysis that was by Ivo Scoots and his team, looking at in the Cochrane analysis. And essentially, we were able to make, in the Cochrane analysis, 4 major clinical claims. And you can see those listed over there. But the important thing is, this was for a prevalence of disease of grade group 2 and above of 30 to 50%. And that's really important to bear in mind. As a result of this, what happened was we got incorporated into clinical guidelines. So the EAU, the AUA, and various other guidelines. And in fact, the fact that we got incorporated into clinical guidelines means that it's like a millstone around our neck, because it makes it difficult to change the guidelines subsequently, because we are now part of standard clinical care. And all of you will have seen these publications, very high quality, in multiple journals, including the New England Journal of Medicine. Okay, so things really changed in 2019. And you can see that as a committee, we've been watching these guidelines, looking at diagnostic utilities. In other words, what is the impact in the community of adopting PI-RADS 2.1? Now, we haven't had many meta-analyses of the 2.1 system, which is a little bit disappointing, but it looks like it's going to be corrected soon. But essentially what we show is at the lesion level, the more suspicious we are, the more likely it is to be cancer. Now we know that, okay? The important thing from your perspective is highlighted at the bottom, and that's here, there. You see that? The number of false positive lesions per case for PI-RADS 3 to 5 is 0.7. So in other words, every 3 lesions that we biopsy, 1 is coming out to be clinically significant cancers. So this is at a lesion level. And this statistic is something that you need to keep in your mind. In other words, the standard of care out in the community, you guys, 1 in 3 lesions that you biopsy will turn out to be a clinically significant cancer. And for a PI-RADS 4 and 5, it's about half. Okay, so that's an important new statistic I'd like you to keep in your mind. The other thing that's interesting is that at the patient level, not lesion, but patient, we see a similar trend. The more suspicious you are, the more likely it is to be clinically significant cancer. Clinically significant cancer, as defined by our literature, is grade group 2 and above. And you can see that trend. The interesting thing is there is very little current documentation on the performance of PI-RADS 2.1 according to the highest risk of prostate cancer, in other words, grade group 3 and above. And this is a big, important piece of data that's missing, and we would really encourage you to publish that data also. It is missing from the literature, which means that the prognostic value is somehow not being proven. Okay. Now, we do see some prognostication of PIRADS 2.1 appearing in the literature. And this is one of the studies that has recently appeared showing that. And you'll see where the arrow is. This was read using PIRADS 2.1 in a prognostic model. In a prognostic model that combines the grade groups and the PSA density to predict biochemical recurrence. Now, of course, biochemical recurrence is okay as well, it's not great as a biomarker for eventual death, but we'd like to improve upon this data. What we'd like you to do is to prove the prognostic value of the PIRADS system. Now, there's been a couple of meta-analyses, and this is one of them. And you'll see that this meta-analysis shows that the sensitivity is about 90%, the specificity is 74% on the PIRADS 2.1 system. Now the question is this believable? And I don't think it is. I don't think it is. Because what's happened now that we've become clinically adopted is that we're not biopsying lesions or patients which we think are negative. We're only biopsying lesions that we think are positive. So in fact, this sensitivity that we are claiming may not be as high as you realize. It may not be as high as you realize. So there's a potential bias here. We need to think about not using the word sensitivity, perhaps relative sensitivity might be a better term. And if you compare version 2 and 2.1, what you notice is that the specificity has fallen. The specificity has fallen in meta-analyses. So you'll see where the arrow is, the specificity has in fact gone down. I can't read that, but you can see the value has gone down. Why is that happening? That's happening both in the peripheral zone and in fact in the transition zone. Because the PIRADS committee says in their guidelines, you should look at the T2 and then upgrade on the basis of a diffusion. What you guys are doing in the community is doing it the other way around. You're looking at something bright on the DWI, and then you are looking at the T2. And just that switch is in fact altering the specificity of the examination. So there's work to be done in trying to more tightly define the PIRADS rules. The other interesting thing about the PIRADS rules is we get this step function, right? So positive, negative, we have this step function, and that PIRADS 3 category is important. The PIRADS 3 category has overall increased in the community. So it used to be less than 10%. Now it's almost 22%. It's doubled. Okay, so there's a little bit of overcalling of PIRADS 3 going on. The other issue is that over half of the patients that we biopsy don't have clinically significant cancers. Okay, so they're either negative or you're diagnosing grade group 1. Okay, so too many men with positive scans don't have a clinically significant cancer. Okay. Now, of course, there are multiple other issues with the PIRADS 2.1 system, and we recognize this, right? So, for example, the diagram's not perfect. We don't have a median lobe, for example. Okay? We don't have a PIRADS 0. So a PIRADS 0, what is that? Well, what's happening at the moment in the community is when a scan is of poor quality, you're going, I don't know what this is. I'm making a PIRADS 3. In other words, you're calling it positive. And that's a bad idea, and that's elevating the PIRADS 3 category. Have to be really careful. So we're thinking about introducing a PIRADS 0 or a PIRADS X, if you like, for a poor quality scan. And please, please, please don't call PIRADS 3 for a scan that you are uncertain of. So if the quality is poor, junk it. Repeat the examination. Don't call it PI-RADS 3, because actually you ruin the reputation of the PI-RADS 3. So the PI-RADS 3 should only be called on a high-quality examination. So why are we waiting to change the rules? Well, in 2022, the American College of Radiology brought out a new rule. And that rule says, any consideration for a clinically relevant change in any RADS system has to account for the predictive effects on patient care, not on diagnostic sensitivity. It's on patient care. In other words, what you say and the biopsy and then the eventual impacts, you have to take into account the entire chain, right? So the evidence rules have changed. So we can't in committee say, oh, I think this might be better than this. Not like PI-RADS, yes? Version 21, I think we're now on, right? We can't do that anymore. We are constrained by the PI-RADS committee about what we can do. The only thing we can do at the moment is watch the literature and watch for any major issues going on, but we've been concentrating on white papers, essentially. So one of these relates to contrast medium. Now, there continues to be this huge debate on contrast medium. Do we need it? Do we not need it? And the PI-RADS committee has essentially not really changed its mind. And this statement here, stating that both enhanced and non-enhanced MRI approaches need to be available for biopsy decisions, still applies. Now, it may be that at low prevalence, so for example in screening where the prevalence is 4%, remember the evidence for PI-RADS was for 40%, right, between 30 and 50%. If it's 4%, then don't give contrast. If there's an obvious cancer palpable, what's the point of giving contrast? But if you're at intermediate or high risk, then you should use contrast, okay? So in a sense, you're going to have to think about the patient and their likely risk. So remember that the current analysis still indicates the need to have both available. Now, it is true that the literature is moving from multiparametric to biparametric, okay? It is true. If you have AI, maybe we can move for those intermediate and high-risk cases, okay? Maybe. But where is the prospective data to show this? There is no prospective data. All you've got is meta-analyses, and these meta-analyses were, the biopsy decision was made on the basis of a multiparametric MRI. It makes no sense, right? You have to be scientifically sound. And this sort of trial, where there is a randomization, not only in reading, but also in biopsy decisions, is what we are going to have to do to produce level 1 evidence that this is the way to go or not to go, okay? And we are, in the UK, we are certainly doing this study, which is looking at over 3,000 patients. Now, there's a number of things other things that you need to think about, and this is about managing demand. Now, you'll remember that originally, we thought about using MRI for 2 situations. Intermediate and high-risk men, biopsy naive, with a normal DRE and an elevated gray zone PSA. And of course, we had men who had previously had a systematic biopsy, and then they were persistently at risk, and we did MRI. And that was the indication, okay? So men like this, for example, big cancer, normal PSA, okay? But what we have seen is creep, indication creep. So, for example, we now have men who were not biopsied, right? Because they were considered at low risk. but have progressive PSA kinetics, right? Now, these patients we didn't have before, but we have loads of these patients now. And of course, active surveillance has also come in as an indication. Now, we have another indication that's appeared, right? And this appeared in the last year, okay? So population screening after risk stratification, in other words, after a prior PSA, okay? And this has now appeared as an indication for prostate MRI. Now, this is more work for you, right? This is more work for you. So this PRAISE-U algorithm, which appeared last year, you'll see step number 3 is all PIRADS. And this could be potentially hundreds of thousands of more examinations for you to do, okay? You need to manage this demand, okay? Now, one of the other issues was we talked about the benefits of MRI, okay? We talked about those 4 benefits for a prevalence of 30 to 50%. Remember that figure, and the benefits are dependent on the prevalence, okay? Now, benefits arise from true results. Harm arises from false results, okay? Don't forget these false results, okay? So we need to decrease the harm of MRI. So, harm of MRI, you're thinking, oh, am I doing harm? I think so. You just need to be aware of it. So, if you look at the harm of MRI, you'll see false negative harm is low and consistent between centers, the graph on the left. So 10 centers, more or less the negative predictive value is the same between the centers, okay? So this means that we consistently miss between 5 and 12% of grade group 2 cancers, consistently, between centers. And that applies to all of you, okay? Which in fact is considered acceptable. Why? Because trust biopsies, systematic biopsies, miss about 30%. So you guys are still doing great compared to trust biopsies. Okay, but look at the false positive harm. So this is for lesions, and you can see there's huge variation between you guys, right? This is not a great record. This is an issue. And this false positive harms, biopsies that do not yield clinically significant cancers, is a real issue. So what we would like to do is we would like to reduce false negative harms, which we know are less, but we also need to reduce false positive harm. Okay? Now, so how do we go about reducing false negative harm? Okay, it's only 10, 12%, but it's there or thereabout. Well, if we chose our patients better, that would be good, right? So raised PSA, family history, single nucleotide polymorphisms, you know, SNPs, loads family history, all that kind of stuff. But PSA density. We could use PSA density. Okay, now, so for example, if you look at the EAU tables, you'll see this table. And in fact, if you look at the guidelines, you can see that the guidelines have now incorporated the concept of biopsies, taking into account the PSA density. So you'll see, when an MRI is negative, and you want to avoid false negative harm, remember, okay, and the PSA density is low, in this particular instance, the recommended 0.15, avoid a biopsy. Okay, so you can see how we can further reduce the false negative harm. Okay, but don't discharge the patients and say, go away. You need to have some sort of safety net. Okay, and you'll see this paper was recently published in the AJR about how to manage patients who have a negative MRI. Okay, and I highly recommend that you read this. Then how to manage these patients. So this is a paper that's well worth reading. The issue really was false positive harm, okay? And we said that we could, that's about 50%. Remember, half the men that you biopsy do not have clinically significant cancers. Well, at the moment in secondary care, we do 3, 4, and 5 is positive, okay? That's what we do. Well, what stops us saying, I'm just going to move the goalpost. I'm just going to make it 4 and 5. Okay? That would reduce false positives. Yeah, that would reduce false positives hugely. Now, so what are the trade-offs? Okay, what are the trade-offs? Now, it turns out 4 and 5 is what you should be using for low prevalence disease. In other words, screening. Okay? So if the pretest probability, i.e. prevalence, is 4%, don't call 3s because that's just crazy. I see you guys doing it, and I see you guys giving contrast for screening examination. That's just the craziest thing to do because all you end up with is false positives. In fact, there was a German study recently because they were using 3, 4, and 5, and they were giving contrast, 80% of under 50-year-olds with a prevalence of 0.26 were getting biopsies. This is madness. Be very careful about the criteria and about the use of contrast medium depending on prevalence. Of course, if a patient's symptomatic, it's a completely different issue. In secondary care, if they're presented at your hospital or diagnostic center after a referral, the prevalence is going to be high. That's going to be 30 to 50%. But if you're doing screening, be very careful because what you could use, this could cause a big issue. Okay, the other thing you could do is use risk calculators and PSA density. So this is the risk calculator that I use for myself. Now, this risk calculator is based in the USA. It suits me because I have a large ethnic population. It may not suit you depending on your population. So the risk calculator has to be appropriate and calibrated to your population. Very important. Okay, but you could use risk calculator, and you can see using a risk calculator improves the specificity. Okay, in other words, reduces false positive harms. The other thing you need to do is to think about the patient in terms of their tolerance to false positivity. In terms of their tolerance to false positivity. Okay? Now, what does that mean? Now, you have to recognize, and in your thinking, I think this is intuitive, that there are going to be patients who are less concerned or more concerned about having a cancer. So you can have patients who are cancer averse, and there are patients who are going to be biopsy averse. Okay? Let me just illustrate that to you. If you look here on the left-hand side, this is a 52-year-old, no family history. No family history, 52-year-old. What's the likely prevalence of cancer here? It's low. It's very low, okay? So he is biopsy averse. He does not want a biopsy, okay? Now, look what happens 6 months later. His PSA has gone up, and suddenly he's saying, well, maybe I'll consider a biopsy. You see how he changed over about 6 months from being biopsy averse to being cancer averse. And this is what you need to take into account. And if you look at the risk calculator, you can see the risk calculator. I can't remember. It's at the bottom. There you go. Risk calculator, you're on the left-hand side, 9.1%, the likelihood of clinically significant cancers. On the right-hand side, 26%. Okay, so you can see that even the risk calculator changes. So He's concerned, the risk calculator's concerned, the AI is saying there's something over here. Maybe you should be thinking about a biopsy, okay, at this stage. So you need to take into account patient preferences, and that's the important thing. The other thing is you need to optimize the pathway after the MRI. Need to optimize the pathway after the MRI. What does that mean? Well, if you're in the USA, you pitch up to a urological clinic, you're getting a biopsy regardless, right? So that's called the risk, that's called the detection-focused pathway, okay? Everybody's going to get a biopsy, but the MRI is only giving you a target. We don't do that in Europe, right? We don't do that in Europe. We apply the middle pathway, which is this one here. Yes, that one. And that is the MRI-focused pathway. That's what we use in Europe. But we are changing. We have now moved towards what's called the risk-based pathway on the right-hand side. So if you have a negative MRI and a low PSA density, then you don't get an MRI. So you can see we are beginning to add risk to positive and negative cases. And in the UK, we've gone even further now and saying, well, not only do we apply PSA density to PIRADS 2 and 3, but we'll also, PIRADS 1 and 2, but also we'll apply it to PIRADS 3. Right? So the important thing is that you need to adjust not only how you read the MRI, take into account patient preferences, but also the strategy for biopsy, i.e. the pathway. Okay? So this is getting a lot more complicated than you thought in the very beginning, right? You thought your job was positive, negative, cha-ching, take your money and leave. I don't think so. Life is changing, okay? Now, the other thing we've seen is AI coming along, and you saw a big ceremony here, a bit scary yesterday. And we know that we can now incorporate it. We can now incorporate AI not only during data acquisition, but also in the analysis. And I'm already doing this in many of my patients. Okay. But when you look at AI devices, there are different classes. There are different classes of AI, and not all AI is exactly the same. And Tobias will cover that in the next lecture. But what you have to remember is you have to think about how AI should be designed. The first thing AI should be designed is to deliver the main benefit of MRI. What was the main benefit of MRI? Avoidance of biopsies. That should be task number one, right? So the first task for an MRI is to focus on excluding patients unlikely to have clinically significant cancers. In other words, missing less than 10% of cancers, right? This is what we said. So that is our standard, okay? When patients are not excluded, it has to detect lesions most likely to represent clinically significant cancers, okay? And then, of course, there are biopsy management tasks that an AI also needs to do. So we can set some standards, and don't worry about these standards at the moment, but the important thing for you to remember is that the PI-RADS committee is now coming into this space and will publish in 2024, hopefully, AI standards. In other words, when you go to the manufacturers in the exhibit and you're thinking about buying software, you should be thinking, does it comply with the PI-RADS standards? Because then that hopefully will guarantee that you will get the benefit that you expect to get. The other thing we need to think about is quality control. And that means not only certification, but also accreditation. Now, certification is about you and your colleagues. Not only you, but your urologist and your histopathologist. And you may have seen this paper that came out a couple of years ago, or 3 years ago now. The important thing here is that the first step is a quality check on the MRI, okay? The first step. And you should, as part of your report, as almost the first sentence of your report on quality. If you're not doing that, please do it, because that would be very helpful. And in fact, PQL version 2 will be coming out shortly. So this is another thing that you need to remember, okay? So you should, at the moment, say what the quality is, and then eventually transition to stating what the PQL quality is. Why? Because your urologist will expect you to do it, right? They will expect you to say, what is the quality of the scan? And if you get a poor quality, don't call it PI-RADS 3. Call it junk. Or eventually PI-RADS 0 if I'm allowed to change the system. Okay. Accreditation is very different. Accreditation is how well you work with your teams. In other words, applies to hospitals, applies to diagnostic centers. And the important thing here is we're looking at the effectiveness of team working. Now, there are a number of principles that we can apply to the accreditation of centers, right? And you guys are thinking, is my center accredited? Well, at the moment, in Europe, nobody's doing accreditation of centers, right? But in America, accreditation of centers is already starting. And what starts in America ends up in Europe. Remember that, yeah? This is the lesson for history, in fact, as it turns out. So it may be that we will end up having accreditations of diagnostic centers in Europe also. Now, when we try to assure the quality of diagnostic centers or team working, there are a number of things that we need to think about. And you might as well start to think about these issues now. The first thing is, in your own center, you have to identify what are the sources of variability for your patients, okay? And how do you control the sources of variability through things like automation, standardization, and how do you better integrate your teams together? The other thing is, what are your monitoring processes? In other words, what are your key performance indices, KPIs, okay? And you think, oh God, what is my KPI? What KPIs? Key performance indices. What should I be measuring in my own center? Well, I think this was really well shown by this paper that was published from Scandinavia. What they did was, you see the red line there, it's 2018. This is where they were monitoring their performance, and they said before MRI and after MRI. And you can see that in their key performance indices, so for example, number of repeat PSA tests, how many biopsies they were doing, how many negative biopsies were they getting, how many indolent cancers were they getting, how many clinically significant cancers were they getting. You can see what happens over time. So this is monitoring your key performance indices over time. And you can see the effectiveness of introducing MRI. Okay? So you should also be thinking about doing this kind of thing in your practice. So, if you put this whole thing together, we have a new pathway. Okay, remember that old, rather primitive pathway, 2019? Only 3 years ago. It's now old, right? This is the modern world, okay? The new quality assured pathway is somewhat similar, but very different, right? So we're talking about pre-MRI risk stratification with the normal stuff, DRE, PSA, and clinical assessments, but we have new methods of assessing the likely risk of somebody having prostate cancer, such as salivary samples and SNPs, for example. Okay? These additional markers are coming. So we'll be able to say patients at intermediate or high risk or patients at low risk doesn't need an MRI. If they need an MRI, you need to do a high quality examination, high quality, remember? And you'll see computer assisted radiological interpretations, right? i.e. AI. Okay, because that will improve consistency. Then there's an integrated risk or adjusted risk of the likelihood of cancer. Then you have to take into account the patient's preference. Is he biopsy averse? Is he cancer averse? And from that risk, you have to do the appropriate MRI-directed biopsy, or not. And then you move down the chain, okay? So we have to be thinking about doing MRI in a slightly different way, in a much more quality-assured framework. And this is where we are going. Okay, so these are the sort of summary points. So PIRADS 2.1 is performing as we expect. It's performing as we expect. The prevalence of PIRADS 3 is going up, which we do not like. Okay, so there is an issue with PIRADS 3 prevalence increasing to up to 22% in the current literature. We need to be thinking very strongly about quality of the pathway and its effectiveness. What impact will that have on patient outcomes? We need to be thinking about new methods of risk stratification. Importantly, remember, we can't just change the criteria because we're in the guidelines. Once you're in clinical guidelines, we need to think about the impacts of the pathway. In other words, the diagnostic utilities that we saw at the end. We cannot just tweak the system based on diagnostic accuracies. Thank you very much for listening. Okay, so I think we'll have questions at the end. Shall we do questions at the end?
There is one question online.
Oh, there's a question online, okay.
But, okay, let's start with that one.
Okay, we've got 5 minutes or so left. Why don't we just take questions for this particular talk? There's a microphone. There are 2 microphones in the middle there. I don't see a microphone on this side. And I don't see any questions from the floor currently. Go ahead.
Okay, so the question online is, should we always perform a full pelvic MRI during the prostate exam in asymptomatic patients?
Should you perform a whole? So it really does depend on prevalence, right? So if you were working in secondary care, where the prevalence is 30 to 50% of clinically significant disease, then doing a whole pelvis to look at the pelvic lymph nodes and bone metastases, probably worth doing, right? Because it will stop the patient returning for an assessment of bone marrow disease and nodal disease in the pelvis. On the other hand, if you're doing screening, where the prevalence is 4%, then no. So it depends. Are we talking about early detection or are we talking about screening? Different situation, different prevalence, different strategies.